All right. Um, a car goes around a curve in a road at constant speed. Explain why, although its speed is constant, it is accelerating. I absolutely love this question. This is, I gotta say this, as a physics teacher, this right here is why IB curriculum is awesome. This is just a great question for students to consider. So let's just go back and really dig into physics. So here we go. First, according to Newton's first, you know what? I'm going to type this because you don't want to read my writing. You really don't want to read my handwriting. So let me just grab a little text box. Whoa, that's not what I wanted. Okay. There we go. Let's go ahead and let's just type a little bit here, and there we go. So, according to Newton's first law, an object in motion remains in motion in a straight line and at a constant speed unless an external force, a net external force, acts on it. So, if a car is changing direction, it's not going in a straight line. That means a net force must be acting on it. And if there is a net unbalanced force, you know what, I'm going to say net unbalanced force. So that means a net unbalanced force acts on it. Thus, it has to be accelerating. Okay, that's one way of looking at it. Here's another way. The car is actually accelerating, is actually changing speed in the x and y direction together. As it slows down in x, it gains speed in y, such that the total magnitude of its speed is a perfect constant. Both of these answers are acceptable. I'm just overkilling and answering everything. All right. Now let's move on to this problem here. So even before I begin this, let's just see what we got. Wow. So here I am looking at this thing, and I'll tell you right now, I'm not going to read yet. I'm just going to give you my impressions as a physics teacher doing this for the first time. So I got a suspicion like they have the marble here. I don't like that. I bet we're going to start it at the top. And I'll just note here that the energy at A is potential plus, well, nothing else. I'm just going to assume it starts at rest. Let me just confirm that, though. Released. We're going to assume that it's at rest. So this is going to be mgh. Now here at B, I think we've got all kinetic energy there. So E at B is just going to be EK, which is 1/2 mv squared. Now at the top here at C, we're going to have mg times this little thing here. I'm going to call it the diameter, plus 1/2 mv squared at C. I'm going to call this B. The other thing, when we're at C, there's a couple things going on here that we should kind of take note of. First, I'm moving in a circle, so I'm going to have a normal reaction force from the track, plus its weight. And I'm just going to write down the equation here, which is that Fg plus R is going to make it accelerate in a circle. And I want to just note that AC here is going to be V at this point C squared divided by the radius of the circle. Those are all things that I simply note as a person taking a look at this problem. I'm just taking all my experience and throwing it on here. I don't know which of these formulas I'm going to use. I'm just writing down every fact that seems pertinent. All right. Consider the marble when it's at point C. Yippee. Let's do that. So what does it say? Wow. On the diagram opposite, draw an arrow to show the direction of the resultant force acting on the marble. I'm not seeing any diagram opposite. Maybe they mean here. So I will draw this. I would say that we have a resultant. So the net force, this resultant force that I will call FR, is going to be this R plus FG. I'm going to write that in blue. This resultant force, this net force, is going to be the R plus the FG added together. So this here is the F net that they're asking about in the problem at C. All right. So I'll write, there we go. Now, state the names of the two forces acting on the marble. Oh my gosh. So I drew this free body diagram. I swear I had not read the question. There's the reaction force. I'm going to say the reaction normal force and the weight or force of gravity. Then it says deduce that the speed of marble is 3 meters per second. Deduce. We could say prove. Let's just do it. So I think that I'm going to use conservation of energy. So I know that E at A equals E at C. So I have mgh at A equals mgh at C plus 1/2 mv squared. So let's go ahead and do this. So I'm going to cancel some things that could be canceled. I want to be careful about this. So I have mgh at A equals m, and I factor it out, gh at C plus v squared over 2, and that's why I'm able to cancel this. If you cannot factor out m from everything, you can't cancel it. I see a lot of careless algebra around that. Now, finally, I'm going to have gha minus hc times 2 equals v at c squared. We'll take that under a square root, and we'll get v of c, and that's going to be here. V of c equals 2 times 10 times, that's going to be 0.8 minus 0.35, that's going to be 0.45. All of that under a square root. And when we actually work this out, that's going to be 0.9 times 10, which is going to be the square root of 9, which is 3.0 meters per second. Awesome. Now it says determine the resultant force acting on the marble and hence determine the reaction force of the track on the marble. Oh my gosh. This thing right here. I swear I wasn't making this up. This is all. Here's the thing with these questions. There's not a lot of physics we can ask you, so I really recommend this. Go through and write down all the facts that you can before you even read the problem. So here we go. Let's do it. The resultant force. So I know that the gravity plus the reaction force. You know what? I'm going to write it the way the IB is. We know that F net is m times a centripetal. We're accelerating in a circle. But the F net we got is Fg plus the reaction force, and then that's m times the v that we got above squared divided by that radius. So here we go. Now Fg, the marble's mass is 0.5. Let me confirm that. Yes, it is 0.05. Sorry. So let's be really careful. Fg, let's calculate it off to the side here. Fg is 0.05 times 10. I see too many people just use 10 or they just use that. You got to multiply these together. So that's 0.5 newtons. So 0.5 plus the r equals 0.05 times 3 squared, which is 9, divided by 0. And let's be clear, the radius is half of 0.35, which is 0.175. So let's be clear, the radius is 0.35 divided by 2. And that's what I'm putting down there. So I can go ahead and actually solve for my reaction force, and when I go ahead and do that, I'm going to get a reaction force of 2.1 newtons. All right. That is an awesome question for this exam.